Imagine for a second that you're running a massive, rapidly growing economy. But there's a huge catch. Your economic survival is entirely at the mercy of fractured global oil supply chains and incredibly volatile conflicts in West Asia. How do you power your nation without just crossing your fingers and hoping foreign oil keeps flowing? Well, welcome to The Explainer. Today, we're diving into a genuinely fascinating geopolitical and technological transition to answer exactly that.
Think of today's session as a strategic briefing. We're going to map out the geopolitical why before we even touch the technological how. We'll look at the big energy shift, decode the different generations of ethanol, look at the ripple effects of this policy, and then expose some pretty surprising hidden bottlenecks. Finally, we'll talk about the way forward and lock it all in with a quick revision. Let's get started.
All right, first up, the strategic energy shift and how we actually go about securing autonomy.
So, the macro problem here is sheer vulnerability. India relies heavily on imported oil. When global supply chains hiccup, the entire domestic economy feels the shockwave. To fix this, you have to build immediate economic resilience. The ultimate goal, transitioning to a self-reliant, climate-conscious energy framework. And look, this isn't just some feel-good environmental choice. We're talking about a critical national security imperative to tackle energy reliance while simultaneously juggling domestic food and water security.
Before we add in all the complex policy and tech, let's establish a really simple mental model. What exactly is ethanol blending? Basically, it's the process of mixing ethyl alcohol, which you get by fermenting sugar or starch-based feedstocks, with regular gasoline. You are quite literally growing a portion of your fuel. Sounds simple enough, right? But the source of that alcohol is where the technological evolution gets really interesting.
That brings us to decoding ethanol generations. We are literally moving from using food to capturing emissions.
Let's chart out how this biofuel technology actually evolves. It's basically a ladder. We start at the bottom with 1G, or first generation. This uses traditional food sources. Think sugarcane, corn, damaged grains. But obviously, using food to make fuel has strict limitations. So the tech evolves to 2G, which shifts smartly to agricultural waste like rice and wheat straw. Then 3G takes us underwater to aquatic sources like algae. And finally, 4G, this is the absolute cutting edge, bypasses plants entirely, using industrially captured emissions and green hydrogen. It's a massive, massive leap from relying on our dinner plates to actually utilizing industrial waste. And this evolution, it creates a radical transformation on the ground for the rural economy. By moving from 1G into 2G, we're taking agricultural surplus and waste and turning it into a highly strategic fuel resource. For farmers, this means a guaranteed, remunerative market that goes way beyond just selling food. It essentially builds a brand new, massive economic engine right in the heart of rural areas.
Okay, let's shift gears and look at the multidimensional policy impact. I like to think of this as the domino effect.
The first domino to fall is environmental, and the impact is huge. We see a 65% drop in greenhouse gases when using sugarcane-based ethanol compared to standard fossil fuels. Even maize-based ethanol cuts those emissions by about 50%. This specific metric is an absolute game changer. It anchors the nation's climate leadership and links directly to hitting those crucial decarbonization targets set under the Paris Agreement.
But the wins aren't just green, they are deeply economic. By replacing imported oil with homegrown ethanol, the country saves a literal fortune in foreign exchange. That helps manage the current account deficit and really stabilizes the Indian rupee. At the exact same time, this policy is forcing the automotive industry to innovate, pushing the engineering of flex fuel vehicles. Globally, it puts India in the driver's seat, exporting its policy playbook as a leader in the global biofuel alliance.
Now consider the sheer brilliance of the circular bioeconomy. You know that severe, choking air pollution caused by burning agricultural stubble in the fields every year? Well, with 2G ethanol plants, that problematic waste is scooped up and converted into a highly profitable industrial feedstock. It's incredibly efficient. We are actively solving an environmental pollution crisis and an energy production deficit at the exact same time. But of course, it's not all sunshine and perfect solutions. Let's dig into the hidden costs and bottlenecks, the systemic frictions. On one side of the scale, we have food security, our essential nutritional crops. On the other side, we have fuel feedstock. These are lucrative crops like maize destined straight for ethanol plants. The hidden danger here is that if government pricing is too favorable for fuel crops, it can severely distort what farmers decide to plant. They might completely abandon essential food crops because ethanol-bound grains simply pay better. This is the classic, highly dangerous food versus fuel dilemma.
And then we run into a glaring ecological paradox. 1G feedstocks, especially sugarcane, are incredibly thirsty. We're talking roughly 1,500 to 2,000 liters of water to produce just 1 single kilogram of sugar. Pushing this intensive cultivation into historically arid regions puts an unsustainable, massive strain on fragile groundwater reserves. Think about it. If you deplete your drinking water just to grow your fuel, you completely undermine the entire green premise of the policy to begin with.
So, what's holding back a perfect nationwide rollout? Let's look at the mechanical roadblocks. First, those amazing 2G plants, they face severe technical bottlenecks because the quality of agricultural waste varies wildly, which can actually damage the machinery. Second, while automakers have built flex fuel vehicles, harsh taxation policies make them way too expensive for the average buyer. Add to that a structural oversupply, where distilleries are producing more than is being procured, plus a wildly uneven production map across the country, and you've got some major logistical headaches.
There's also one more critical reality that often gets brushed under the rug. The net environmental benefit is frequently compromised by the sheer colossal energy expenditure required during industrial distillation. Getting the bioethanol ready, the pretreatment and distillation phases, sucks up massive amounts of energy. You really have to ask yourself, how green is the entire life cycle if the factory process itself is eating up so much power?
So knowing all that, what is the strategic way forward? How does this evolve?
Let's map out the flow from today to tomorrow. Right now, the immediate target is a nationwide E20. That's a 20% ethanol blend in our fuel. Moving into the near future, testing is already happening for E21 and E27 blends, pushing automotive boundaries even further. But make no mistake, the ultimate long-term endgame has to be a complete systemic shift away from 1G food crops. We need to move entirely towards 2G waste and 3G aquatic resilience to make this work.
To truly resolve that food versus fuel clash, and to stop draining our water reserves, we desperately need aggressive innovation. We have to see a balanced shift toward those advanced biofuels, backed by rock-solid policy integration that champions non-food-based tech. Honestly, it's the only viable path to making this entire energy framework sustainable for the long haul.
All right, we've covered a lot of ground. Let's jump into a rapid final revision for true concept mastery.
Here are the 5 absolutely crucial takeaways you need to remember. 1. This whole strategy was triggered by the urgent need to escape foreign oil dependency and geopolitical chaos. 2. The technology isn't static. It evolves like a ladder from 1G food crops all the way up to 4G emissions capture. 3. The macroeconomic impact is massive. It stabilizes the current account deficit while pumping money into the rural economy. 4. It is, however, plagued by real limitations, specifically the food versus fuel competition and severe groundwater depletion. And 5. To survive, the future demands urgent, massive innovation in 2G and 3G frameworks to bypass those exact bottlenecks. I want to leave you with one final provocative question to chew on. Can a nation actually achieve true energy independence without compromising its fragile food and water security? It really is the ultimate strategic balancing act of our generation. Think about how these interconnected systems are going to shape the world we're building. Thank you so much for joining me for this explainer. Keep analyzing and keep learning.